Hello and welcome everybody. Thank you for listening to my presentation. Um, I'd like to begin by asking you a question. Do you believe that progress moves in a straight line? Because I think the truth is far from it. In fact, progress contains within it certain phase transitions where we things change very dramatically. I mean, imagine yourself as a hunter gatherer who was just looking to the neighboring tribe as they began to plant their crops, or then again as a farm laborer who uh, noticed the mechanized plow trundle into the field. These were moments of great change, moments where that reshaped entire industries and societies. And make no mistake, we're at the beginning of one of these such phase transitions right now. So it's hard for us humans to imagine what these exponential shifts are like because they appear to be going slowly, 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 a little bit faster, and then whoosh, they're off like a rocket. Now, project yourself a little bit into the future. Imagine an organization where you're able to ask any question in natural language with all of the knowledge of the web compressed within there, and then all of your internal data stretching across wherever system that it's currently in. And I think this may sound fanciful, but within, I don't know, somewhere between the next 5 to 20 years, this is what all organizations are going to have to be like. So I've been thinking about this and experimenting with it all for quite a long time now. And what I'm going to attempt to do in the next 20 minutes is lay out a rough architecture that could be used within any organization. Okay, so where do you start? Well, you start with what you already have. Don't become frozen by the mesmerizing brilliance of GPT chat or disorientated by the dizzying speed with which the tectonic plates of technical AI are moving forward. We all know that AI is like a kind of glittering iceberg, that beneath the surface, there's a kind of murky underworld of data pipelines and curating and cleaning and vast, vast, vast sets of data. And while some organizations may be blessed to be in the position that they can pull all of that data off the internet, that's not true for the majority of organizations. So you've got to work with what you've got. And the truth is, we've all got a lot. We're actually like beggars sitting on top of gold mines because you've got all of those database and information that's been collected and curated over all the years. You've got all the experts that understand how that applies. So I'm going to try and give a few clear messages. And here is the first one. You need to do one thing right now as fast as you possibly can. You need to connect and organize and consolidate all of your data. Yes, all of your data that you already have. And when you've connected and consolidated that together, you too will have a vast data set on which to train your AI on. Okay. But if you work for a large organization, your current data is in a mess. From a bird's eye view, the whole and at the level of the whole organization, it's so chaotic and disorganized that it's hard to see how you're ever going to make any kind of systemic sense of it. How do I know that your data looks like this? Because this is the situation almost every organization is in. The applications are currently holding the data hostage. And as a result, the information of the entire organization has become fractured and fragmented, scattered across 1,000 different applications and databases. It's very hard to see how we ever put this back together again. The sheer complexity is overwhelming. What's the answer? Well, in an organization of any size, the answer is certainly not one big central database, data warehouse, data lake, or knowledge graph. That's what we've been trying for the last 40 years, and it's simply not working. But we need to challenge some assumptions as we move through this paradigm shift. So far, we've assumed that the only way that we can integrate information is to bring it together into one big central store. Underlying this assumption is that the responsibility for integrating data is always upon the consumer of the data. And the problem with this method is it can't scale. It has consistently failed to link than a tiny percentage of any organization's overall data. And think about it, right? This failure is not surprising. Each individual application is like a complex system in its own right. And there's no way that one central team and one central database can consolidate and merge all that complexity into one system. To be clear, this is not a technical problem. This is a people problem. You can't scale the human effort needed to clean the data, by using one central team. It's clearly time to change. It's time to pivot to a decentralized model. And the decentralized approach now has a name. It's got a trendy name, the data mesh. And the data mesh emphasizes decentralized ownership, domain specific data products, and a self service data architecture. The data mesh is taking the business world by storm, but beware. Simply exposing raw, unconnected data without first conforming it will end in tears. Without consistent semantics, you'll just have created a distributed version of the data lakes that have already failed. You won't have addressed the fundamental underlying data integration problem. The cost of data integration can't just be magicked away or sidestepped. So, okay, we need decentralization, but we need a connected data mesh. We need a data mesh with clear and consistent, well-organized semantics. Now, if we're thinking about data integration, you can't really do that without thinking about the relationships that join things together. That's the integration part. So we need to start there by paying more attention to the relationships that connect the data items together. And we need to build that connectivity down into the very structure of the data itself. Now, the main data structures that everybody is familiar with today are tables, like your relational databases, and Excel spreadsheets, and trees, which are like folder structures or JSON or XML. But those people attending the Knowledge Graph conference will be well aware that a new data structure has slowly been rising up, the graph. The graph is a data structure that treats the connections between things as first-class citizens. The relationships are as important as the data items themselves. And this is a data structure that can meet the data integration problem head on. The flexible nature of these graphs also means that they can model both tree-like and tabular data structures with ease. And graphs can even model quite complex concepts and thus provide islands of certainty in images and text. And we'll return back to this as time goes on in the talk. And in this sense, the graph doesn't replace the other data structures so much as provide a universal way of representing them and, crucially, of connecting them together. But graphs are really complicated and the semantic web has failed and blah, 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 right? Well, wrong. Let me tell you about JSON-LD. JSON-LD adds 3 simple properties to the top of the JSON syntax that the vast majority of developers are already very familiar with. These 3 properties magically turn plain old JSON into a fragment of a distributed graph. First of all, we have the ID property. And the ID property allows us to assign a URL to every data item. So now each data item basically has its own web address. And then if we want to reference 2 data items together, we can just use the URL of the other data item. For example, a person's colleague property can have another person's URL there as its value. This is not rocket science. It's exactly the same way that we link 2 web pages together on the web. Finally, JSON-LD has the context property that links data items back to the schema and semantics related to what that data item is about. And I'll go into that again shortly because it's a key innovation. But here's the key revelation that I want to impart to you now. Nearly half of the web now contains these islands of JSON-LD. 44% of all websites now have these little islands of JSON-LD. So make no mistake, this is data integration happening at a global scale. Okay, I touched on it briefly before, but let's move into the at context part of JSON-LD because it's one of the really cool things about it. Because of all those islands of JSON-LD, they're basically pretty much all pointing back to one shared schema, one shared ontology. We can take the definition of recipe as an example. So out there are thousands and thousands of web pages which include all the descriptions of what a recipe is. And in them, embedded there, is a little island of JSON-LD with the data of what the recipe is. And each one will use the same properties that are specified in schema.org. The cooking time, the dietary restrictions, the ingredients, etc., etc. Well, what's the benefit of this? Well, it means that if I can now go into Google and search for a spicy bean burrito, Google isn't just searching text, it's searching the data as well. It's searching its knowledge graph and returning very precise results. The magic here is that the cost of the integration has been pushed from the organizations collecting the data to the organizations providing the data. The search engines have been able to invert the data integration problem. And this inversion of responsibility enables integration at a limitless scale. Think about this for a second. Schema.org provides us with an example of data integration at a limitless scale. So, things are getting more concrete now. The name of the game is not to get distracted by the glitter of fancy AI, but just to concentrate on consolidating all of your organization's data. That's where your value is. So you've got to consolidate it. And now we've got a proven way to do that. Schema.org is open source, so you can just download it and run it from within your organization. Your schema.org can host the concepts that are relevant to your particular organization. For example, if you're a pharmaceutical, you will start by adding things like drugs and drugs trials here, whereas if you're an investment bank, you'll add concepts like trade and risk. It's very important that these concepts mirror the everyday words that the business uses to talk about their business. For reasons that will become apparent shortly, its business semantics and the data semantics should match up as seamlessly as possible. Remember, we are at the start of a technological phase transition. Conventional wisdom about it not being possible for an organization to agree upon a common foundational model can no longer be trusted. The whole point of a paradigm shift is that the conventional wisdom changes as you move through it. So please allow me to be blunt. There is no more time for petty squabbling about what your base definition of what a customer is. We're in the middle of a technology change. Time is ticking. You need to integrate your data or die. Okay. Slightly lighter note, we're ready to return to the data mesh because we can now think about creating a semantically enabled data mesh. Schema.org allows us to build this linked data mesh made up of semantic data products. Each application can publish their JSON LD, just like the websites do on the web, and they can, where possible, they're going to conform to the shared model hosted in your internal schema.org site. And when one application has data related to another application, they can use the URLs to link the two items together. In this way, each application is publishing a fragment of an overall distributed graph. This is a scaleless architecture. You can use it to consolidate all of your organization's data. Now, data products don't just publish the JSON LD, they can consume the JSON LD as well. Creating a single knowledge graph database that encompasses all of your entire enterprise is both undesirable and unfeasible. Let me be clear about this. It's a big mistake to think that way. Most companies that use knowledge graphs have extensively already have multiple instances of their knowledge graphs. So let's embrace that pattern and just turn it up to the max. Each semantic data product, which can be aligned to various use cases, teams, individuals within the organization, can have its own graph database. Let 1,000 knowledge graphs bloom within your organization. By having multiple knowledge graphs, companies can focus on specific domains and use cases, and new knowledge graphs can be added or modified without affecting the overall system. This approach allows for better scalability because you don't have to worry about keeping alive this huge, flaky, trillion-edge graph database. But although the semantic data products are decentralized, of course, we want to treat everything as if it's all one large connected graph. And how can we do that? Well, the answer is surprisingly simple. The good old data catalog. A data catalog is a centralized list of all the data sets within your organization. And let's face it, it's had mixed success. But let's take that well-established pattern and apply the integration cost inversion on it. We can do this by simply adding a definition of what a data set is into your internal schema.org. And now the responsibility is on every application to tell the business, these are the data sets that I have to offer you. Here is my data catalog of the data sets that the rest of the organization can use. The central Organizational level data catalog now simply has to go out to each of these semantic data products and pull in their individual data catalogs. And then the algorithms that span the entire organization can traverse these various different data sets and knowledge graph, crawling from one to another to gather the information they need. Okay, we've come a long way in a short period of time. I know there's obviously quite a lot to take in, but we have the core architecture in place now. The semantic layer maps the complex data infrastructure of your organization into familiar terms such as product and customer or revenue. And it offers a unified, consolidated view of all of the data across your whole organization. Let's just quickly run through each component again. First of all, we've got the yourschema.org website, which is the internal version of schema.org, which you can use to have your shared ontologies and then map from there to downstream BI and AI tools, providing business-friendly understanding of all of the data across the organization. This is often the classic part that's referred to as the semantic layer. Then we've got the linked data. So each application can have a data service over the top of it, which is helping surface its JSON LD, which is forming the distributed graph of connected data sets. And finally, to pull it all together, we've got the connected data catalog that organizes the linked data sets by the concepts defined in your schema.org. This semantic layer architecture makes technologists consciously think about defining their semantic data products in a way that directly delivers business value in business terms. And that turns out to be really quite important. Okay, you've all been very patient. With the semantic layer architecture in place, that's now given us the kind of submerged data part of our AI iceberg. We've got it in place. And so now we've got that engine, let's add the rocket fuel. I'm sure you've all heard of ChatGPT. GPT's embedding vectors are numerical representations of the text, and this allows the machines to analyze and understand the language. GPT learns these embeddings by reading the text on the web. And that text resembles a kind of fuzzy, nuanced sea of complex human communication. It's very powerful, but also somewhat inaccurate. It can hallucinate, it's loose, it's nuanced. But remember, almost half of those web pages now contain islands of JSON LD. So floating within that nuanced sea, fuzzy sea of text are concrete, precise islands of data. And I believe they're included in the learned embedding vectors. You see, these structured data islands, they serve as anchor points for machine learning algorithms, enabling the algorithms to understand the context and meaning of the text. The islands of JSON LD ground the surrounding text in concrete facts. But here is the exciting part. You can reverse that relationship and use these islands of JSON LD to connect GPT back to your own internal data. The JSON LD can be connected into the data you hold in your own private databases. The semantic layer of your organization can be used as an interface that can connect your internal data into the general intelligence of the large language models. Let's just run through how we do that. So GPT is partly trained on JSON LD, so it can answer back in JSON LD as well. You can put a natural language question into GPT and you can get the answer back as a JSON LD graph. Now that JSON LD graph is going to map into the ontology of schema.org. Now your semantic layer architecture would mean that now your own internal data is also accessible in JSON LD too. So then what you can do by using well-known URIs is connect into the JSON LD within your organization. So a question goes into ChatGPT, back comes a graph of the data representing that with the known entities in it, and then you pull up from your internal data anything that connects into that. And because JSON LD is a graph structure, the two graphs can be combined with ease. So your data and GPT's answers are merged into a single connected graph. This kind of creates like a sort of a working memory of which now I can either kind of go back into my internal data within the organization, or I can reach back out into GPT's knowledge of everything that it's learned off of the web. But it goes deeper than this. If you make your semantic layer use the terms that have been defined by your business people and keep it as close to those business terms as possible, you can also then begin to take your documentation and all of the documents that you've got within your organization, running your own internal large language models over them to create embedding vectors, and connect those back into the concepts. And on the other side, if you base your own internal version of schema.org upon the ontologies that have been defined on the schema.org that's out there on the web, then your ontology and the ontology that the large language models, the generalist large language models like GPT chat out on the web have been trained on, they're going to mesh together all the better. The concepts are going to be closer. So this means that two things. It means you're getting the general knowledge from compressing the whole of the web. You're getting your private data, and they're being connected together rather seamlessly. And then you're also kind of getting that fuzzy world of nuanced text, both externally and internally now. And that's being connected into the data. At the end of the day, it's all just semantics. So this will let organizations, pretty much any organization, use this powerful new AI technology without compromising their own internal privacy. Okay. So, my fellow innovators, as we look towards the future, I think it's clear to see that we're about to enter a very exciting period. We're on the cusp of a technology revolution that promises to reshape the world as we know it. But amidst all this excitement, there's a personal fear that's been lingering in my mind, and that's a fear that at the end of this revolution, we'll lose the rich diversity of the current ecosystems of companies that exist around the world. Instead of having multiple different players, each with their own autonomy, everything collapses down into a few giant central AIs. The ideas that I presented here today are not a product. That's not what we need, or at least that's not all of what we need. We need a shared architecture that can be used by all organizations. So use the images and words that I've published here and on LinkedIn and Medium. They are a gift freely given to you. Use them to deliver the following simple message to your CEO. You need to start building your own schema.org today. You need to use it to connect your organization's data together before the exponential curve of AI really kicks in, or you're as good as dead. This is a very rapidly changing situation, and I certainly don't claim to have all of the answers. But by thinking out loud and sharing my thoughts with you here today and in other forums, I hope that other interested people, we can all come together, and through a collaborative process, we can establish a shared set of architectural patterns, standards, and open source tools that all organizations, large and small, can adopt. By doing this, we will be able to shape the future of what this AI looks like. So I appreciate any of you and welcome any of you to come and follow me on LinkedIn, read my Medium articles. Your comments and contributions, even if they're challenges, are useful for developing this debate. So I look forward to connecting with you, and together I'm sure that we can build an ecosystem where innovation is not limited to a selected few, but is available to all. Thank you. And I think I've gone slightly over time there, but I'm now open to any questions that anybody may have. I'm just being told we don't have time for Q&A, so I'll just say thank you, and let's chat on LinkedIn. Come and follow me on LinkedIn.